vein. We did arteries, we did veins.
Yeah, we did.
Yeah, we did.
I was sure we did. I promise.
That's what we did.
Right, and the digestive.
Right.
Okay.
We know we did that already.
Oh, pH.
pH.
Oh my gosh. They did the kidney. So. What did we test on for the fluid?
Wait, you're already in the pH.
We have the digestive system.
Yeah, we have already done the urinary.
Yeah,
we did that.
We're doing digestion, everything that's happening, we're doing
And the
pH. And we're doing pH.
We're doing pH.
Can we go some pH levels on the
So you guys feel pretty good about digestion?
Yeah.
That's straightforward. And then, probably the only tricky thing on digestion is this one, because we just don't think about that too much.
Yeah.
So this one, we know we're talking about liver here. Our liver cells are hepatocytes, individual brown things. We have our portal triad, the hepatic artery, vein, and bile duct. They are all draining towards the central vein. How they get there are through the blue things, the sinusoids, if we're coming from the vein. The canaliculi if we're coming from the bile duct. We're all draining towards the central vein. Oxygen-rich blood in the artery, obviously. Nutrient-rich blood in the vein. And what's in the bile duct? Bile. And it's going through those little green canaliculi. And what does bile help us do?
Digest
fats.
fats.
Yeah.
Break down fats. So that's this. The rest of the digestive system pretty straightforward. And then if we're looking at our liver, right lobe versus left lobe, and we have our vena cava here, inferior vena cava. If we flip it over, we have our gallbladder inside, and the quadrate lobe, QU, is located next to the gallbladder, and the caudate, CAU, is located by the vena cava. Hepatic artery, hepatic vein, and then the bile is coming down the cystic duct, cyst for bladder, cystic duct, and then we're going to have our right and left hepatic ducts in there coming to the common bile duct. So if it's coming off the gallbladder, it's the cystic duct. If it's in the liver, it's the right and left hepatic, and then they're all going to drain down into the, where do they drain?
Common.
Into the common, yes, and then into the hepatopancreatic ampulla in the corner of the duodenum. Okay, so that's digestive stuff. Then the pH lab, let's review that.
Yeah, me too.
So pH lab, remember we started off with, we did samples of different things, we did coffee, milk, apple juice, grapefruit juice. The only thing that was alkaline in that was milk of magnesia. Everything else was an acid. So that was experiment number 1. And they'll say something like, which of the things was alkaline? And then we did the choices of what we used. And then we went on and we talked about buffers. So our milk of magnesia came in at about 9, pH of 9, which is too alkaline, too basic. And so we wanted to buffer that. And how we buffered that was with protein powder. Remember, we can buffer things with protein in our body. So we took that pH of 9, milk of magnesia, and we wanted to bring it down to 7-ish. And so we buffered it with protein powder, and we brought that from 9 down to 7, and then we buffered it or neutralized it. That's experiment number 2. So it might say, in the experiment with milk of magnesia, what did you use as a buffer? Protein. Yeah, what happened when we put the protein in there?
Neutralized.
And did protein act as an acid or a base in that situation?
Acid.
Acid, because we were already too high base, so we took it. So that's experiment number 2. Then we talked about we have physiological buffers, the lungs and the kidneys. So in experiment number 3 with sodium hydroxide, we used what as a buffer?
Carbon dioxide.
So we use our respiratory system. And what did we use as an indicator?
Phenolphthalein.
Phenolphthalein. In that little bottle. What does phenolphthalein do? It turns one of two colors. Clear or purple? Clear equals
Acidic.
acid, purple equals
Basic.
So what, when we tested in experiment number 3 with sodium hydroxide, what color did we turn? We turned the purple.
We started out
We
with
turned clear.
Clear, yeah. And then we blew in carbon dioxide, so we buffered that sodium hydroxide with our respiratory system, carbon dioxide. We blew acid into it, and it turned clear. So what were our 2 indicators that we took our strong base, sodium hydroxide, and neutralized it? What 2 things did we use to determine that?
We used carbon to.
Right, we used our CO2, and then we knew it became more acidic or neutral because we saw
color change.
clear, and we did a pH. So that was our 3rd. And the 4th and final experiment with our vinegar baking soda, we started off with vinegar, which is a very strong acid. And how did we buffer our acid?
With sodium bicarbonate.
Sodium bicarbonate baking soda. So we used, and that replicates which system?
Renal.
So we used sodium bicarbonate, HCO3, well, NaHCO3. So we used our bicarbonate as a buffer. We were trying to replicate the renal system in that one. And we did, we buffered it, and we took that pH of 2 up to neutral 7. So which way did we shift in that reaction?
To the left.
On that equation, we shifted to the left. In the first one, we shifted to the right. So now, all of that, and those are the kind of questions they'll ask. The last part of that is they'll give you these values. So remember when we're talking about pH, you want to know, are we within normal, 7.35 to 4.5? And if not, there's 2 things we're going to look at, carbon dioxide and bicarbonate, respiratory and renal system. So the respiratory, anything having to do with CO2, that's going to regulate or buffer our system. So if our pH is out of balance, we want to go over and look at the CO2 and see what's happening. Are we in acidosis or alkalosis? Or we want to look at bicarbonate and we want to see, are we within range? If not, are we acidosis or alkalosis? If it's a CO2 thing, it's respiratory, acidosis or alkalosis, if we're out of range. If it's anything other than CO2, we're going to look at that bicarbonate, HCO3, and then we're going to be in renal or metabolic. They mean the same thing, renal or metabolic acidosis or alkalosis. So we're just going to follow this flow chart, and whatever it says, that's what we're going to write down.
So we will have the flow chart?
Yeah, the chart will
Okay.
be there. And it has your key up here, it's exactly like this page, and then you're just going to follow it down. So just follow it down. And that will be what it is. Digestion, pH, and
I have to be able to